Okay, so you've got a couple problems in your homework and in the book that ask you to put a quadratic function in vertex form. That is this form here, where you get a times the quantity x minus h squared plus k, where h, the ordered pair hk, is your vertex. Okay, so let's the first thing I'm going to do is let's rewrite this. Instead of p of x, for simplicity's sake, I'm just going to call it y. So we've got y equals 3x squared plus 4x minus 1. Now we want to put that in the vertex form. And we're going to do something called completing the square. And basically completing the square is we want to get the right side into a form that's factorable into this x minus h squared. So the very first thing you want to do is you want to get this term here, the x squared term, to be just 1x squared. You don't want it to be 3x squared. So we want to get rid of the 3, and the way we can do that is we can divide both sides of the equation by 3. And remember, we're going to have to divide every term by 3. So we're going to divide every term on both sides of the equation by 3. So we get y over 3 equals, now the whole reason we did this is because we want this to just be x squared, which it is now, plus 4/3 x minus 1/3. All right. The next thing you want to do is to get rid of this term here. We don't want that minus 1/3. We want to get rid of the constant term. And the way we get rid of it is we're just going to add it to both sides of the equation. We want it basically to end up on the left side over with the y over 3. So we get going to add a 1/3 to both sides of the equation. And so now we get over here, we're going to get y over 3 plus 1/3 equals x squared plus 4/3 x. All right. This is the part where we're completing the square. We want to take half of the coefficient of the x term. So here's half of our coefficient of the x term. And really what we're trying to do is we're trying to find out what number we should add here to get this whole right side factorable into something that'll factor into x minus some number squared. So in order to do that, we're going to have to take half of this 4/3. So I'm doing that over here. We got half times 4/3 is going to be 4/6, which reduces to 2/3. So we're going to take half of that number, right? And we're going to take this number, this 1/2 that we just got, and we're going to square it. So we're going to take this number here and we're going to square it. So 2/3 squared equals 4/9. And this is the value that we're going to add to here. Now we can't add it to there without adding it to the other side as well. So let's do that. We're going to get y over 3 plus 1/3 plus the 4/9 that we just found equals x squared plus 4/3 x plus 4/9. Okay. On the left side, we can just add these together. 1/3 is the same as multiplied by 3/3. So 1/3 is 3/9. And so I guess I'll do that over here. 3/9 plus 4/9. So on the left side, we're going to get y/3 plus 7/9. And on the right side, the whole reason we went through all that trouble to figure out what number to add there, that 4/9, is because this now is a perfect square trinomial. We can factor the right side. Right? We can factor the right side of this. We're at step 5 now. We can factor the right side of this into x plus 2/3 quantity squared. By the way, that 2/3, right, that's the same number we got over here and that we squared. And that works because if you multiply it out, you know the last term is going to be 2/3 times 2/3, which is the 4/9. That's why we squared it. And when you multiply it out, you'll get two middle terms that are 2/3 x. And that's where when they add together, you get the 4/3 x. That's why we took half of that. Okay, so the hard work is done. The rest of it really is just getting it back to y, getting it solved back for y. So we get y/3 plus 7/9 equals x plus 2/3 quantity squared. Let's subtract 7/9 from both sides, right? We're trying to get that y by itself, so I'm going to subtract the 7/9 from both sides of the equation. And on the left side, we're going to get y/3 equals, and then we're going to get the quantity x plus 2/3 squared minus 7/9. And the last thing we need to do to solve for y is we need to multiply both sides of the equation by 3. So we're going to multiply the left side by 3, and we're going to have to multiply the right side by 3. Be careful because that whole term's got to be multiplied by 3. So on the left side, when you multiply this, the 3's are going to cancel. You're going to be left with just y. And on the right side, when you multiply this, it's going to be 3 times that whole quantity. So I'm just going to write it like this: 3 times the quantity x plus 2/3 squared. And then it's going to be 3 multiplied by the 7/9 or minus 7/9. And for that, the 3 and the 9 will cancel, so you're going to end up with minus 7/3. So that's it. We pretty much have it in the form that we want. I'm going to put it back sort of in the original. I'm going to replace the y with p of x because that was our original formula for this. And then we got 3 times, and since we want it in that x minus h form, I'm going to rewrite this. You can think of this as being x minus this negative 2/3, and then squared minus 7/3. And so if you remember from this form, our vertex, right, this is h and this is k, our vertex for this parabola then must be negative 2/3, negative 7/3. Now if you want, you could go check. You could graph this in this form, right, in the vertex form, and you can compare it to the graph of your original polynomial function in standard form. They should match up. And if you look at this, the vertex should be at negative 2/3, negative 7/3. It should open up, right, because this number a is positive. And because it's 3, it's greater than 1. It's providing a vertical stretch here. So it should be tall, skinny parabola that opens up with a vertex at negative 2/3, negative 7/3. All right. This is useful for other stuff. There's, I don't know if we'll have time, but if we get to conic sections, this completing the square comes in handy. You can look at the formula for the quadratic formula. It's basically it's derived from using this completing the square on sort of the general equation ax squared plus bx plus c equals 0. So if they do that, there's no numbers, they're doing all the same thing, but they end up with the quadratic formula. It's a version of this completing the square thing. Okay, so I hope that's helpful.